Hi everyone, I'm Achini Jayasena, a senior software QA with the focus on quality engineering and identity access management. In today's sessions, we will look at how quality engineering supports continuous delivery and why it's crucial in today's fast-moving software world. I walk you through how Cypress fit in this picture, not just as a testing tool, but as a driver of continuous delivery through quality engineering. We've seen the big picture, quality, speed, and confidence coming together through QV. Now, let's zoom in on the foundation, continuous delivery. What does it really mean? How is it different from continuous deployment or continuous integration? Understanding that distinctions help us see exactly where QA Cypress where QE and Cypress fit in. So, in modern engineering practices demand that code is always ready to go live. We achieve this by making small, frequent changes, validating them automatically, and ensuring stability across the environment. So in these steps, team don't wait for long release cycles. Code is automatically built, tested, and verified. So we are always ready to release. Before diving into how Cypress fit into continuous delivery, let's clarify what it means compared to continuous integration, continuous deployment, and continuous testing. So the content integration. Continuous integration is the first step. Every time code is committed, it's integrated, built, and tested automatically. This reduces integration error and keeps the code base stable. Continuous integration ensures team catch issues early, but by itself, it doesn't guarantee deployment to production. Then continuous deployment takes automation a step further. Every code change that passes continuous integration and verifying automatically in different stages, for example, dev stage environments, and automatically deploy to production. It's emphasize speed plus zero downtime. Now, what is continuous testing? Continuous testing ensures quality at every stage. Instead of relying on heavy manual testing at the end, automated tests run continuously alongside development. This gives real-time insights into quality and make fast feedback possible. Cypress, as we'll see, is a strong enabler here, especially for reliable UI and end-to-end testing. What is the difference between continuous delivery and continuous deployment? Continuous delivery is commonly used when systems handle high-risk user scenarios. Organizations need extra layer of control, governance, and compliance before pushing changes to life. The product is always in a deployable state, but the actual release to production is a business decision. It's not just a technical one. So most often seen in we can see this in we can see this in enterprise systems, but can also apply in SaaS when risk is high. So far, we've seen how continuous delivery and continuous deployment-driven modern software releases. What really matters is both approaches is that the system is always production ready and backed by a strong continuous testing. That doesn't just happen by accident. It requires continuous testing backbone that gives fast, trustworthy feedback. This is exactly where quality engineering comes in. Unlike traditional QA, QE, isn't just about finding bugs at the end. It's about building quality into every stage with collaborations of everyone in the team, from development to release, so that production readiness is constant, not a milestone. But even the best QA mindset need the right tooling to make it real. And that's where Cypress provide unique values. With Cypress, team can run fast, reliable, end-to-end tests that integrate directly. This gives confidence that every change, big or small, is validated continuously. So, whether your business chooses continuous delivery or continuous deployment, the combinations of QV principle plus Cypress tooling ensure you can deliver software with speed, stability, and confidence. We've seen that whether an organization chooses continuous delivery or continuous deployment, the real foundation is keeping the system always production ready with strong continuous testing. But here the catch, testing alone isn't enough. The true make this worse, that truly make this work at scale, we need to change how we think about quality. It's not just the job of QA anymore. It's the responsibility of whole team. This is where quality engineering comes in. Let's take a look at what QA really means, how it's different from traditional QA, and why it's critical for enabling continuous delivery. Quality engineering is a modern evaluations of QA. Traditional QA was most about testing at the end of the cycle, finding bugs and handing them back to the developers. Almost all the testing tasks done by a dedicated QA team separately. But in today's world of continuous delivery, that approach just isn't enough. We can't afford to wait until the end to check for quality or treat it as a sole responsibility of a QA team. So QE is about shifting quality left, embedding embedding it into every stage of life cycle. It means QA engineers, developers, and stakeholders work together to build quality instead of testing it in later. A key difference is that QA is preventive, not reactive. Instead of asking how many bugs did we catch, we ask how can we design process and automate so those bugs never appear. So QV isn't just a role; it's a mindset and practice that make continuous delivery truly possible. So let's see traditional QA versus quality engineering. In traditional QA, quality often felt like the responsibility of one team at the very end of the process. Developers wrote code, then threw it over the wall to QA to find the bugs. But in QA, quality becomes a team sport. Developers, product owners, and QA engineers all share responsibility for delivering a reliable product. That doesn't mean the QA team disappear. In fact, their role become even more crucial. They set the standards, bring in automation, ensure processes are in place, and act as a quality coaches for whole team. So the big shift is QA owns testing, QE makes quality everyone's job, with QA engineering leading the way. So the shift from QA to QE is really two things: a process change and the right tooling to support it. The process defines how we approach quality, embedding testing earlier, automating more, and making it shared responsibility. But here the truth. Even the best process can feel heavy if you don't have the right tools. Once we found the right tools, in our case it's Cypress, the process becomes much easier to adapt and scale. But before I get into how Cypress fit into this story, let me first walk you through the process side of the shift, how we actually adapted our approaches to quality engineering. So to make quality everyone's responsibility, we change both the mindset and the process. Developers now write tests along with their features, unit integration, and end-to-end. So quality is built from the start. QA engineers shifted from tester to quality enablers, focusing on frameworks, strategy, and mentoring. We added peer review for every fix. Another developer verify the issues and change before merge. And for the critical ones, developers pair up and do validations. This built actually the trust and shared accountability. With automation, shared dashboard, and continuous integration pipelines, quality becomes part of the workflow, not just a final checkpoint. Okay, so far we've seen that continuous delivery is only possible when teams embrace quality engineering, collaboration, automation, and continuous testing. But having the right mindset isn't enough. To make QE practical and scalable, we need the right tooling. And this is exactly where Cypress comes in. It's bringing development and QA, make testing faster, more reliable, and ultimately enabling us to achieve a continuous delivery with confidence. So one of the biggest reason Cypress works so well for us is that developers actually enjoy using it. Which you can't say for most testing tools. It's developer friendly, but it's built with JavaScript and TypeScript, so there's no learning curve to context switching. It gives fast feedback, test run quickly locally and in pipelines, and the Cypress dashboard shows result instantly. So developers usually run tests before pushing codes, catching issues early and saving times. So debugging is smooth and visual with screenshots, videos, and time travel through each steps, making complex IAM issues like multi-factor authentication or redirects easy to trace. So it supports real IAM scenarios like multi-factor authentication with QR codes, TOTP, password reset, and federated SSO. Plus, we built a common test framework with reusable methods so anyone on the team can add new tests easily. Cypress also lets us combine API and UI testing, speeding up execution and it's reducing flakiness. And finally, it promotes shared ownership. Developers ship their features and their tests, building confidence and collaboration across the team. So before we jump into the Cypress in action, let me briefly explain what an IAM system is and why it's tricky to test. IAM or Identity and Access Management System stand for its security, authentication, and authorization cases. So it's the backbone that control who can log in, how they authenticate, and what they can access once they inside the system. So in our testing, we are not just checking if a button works. We are validating security critical user journeys that span multiple systems. For example, a user signing with Google, setting up MFA, getting redirected back to their application and receiving tokens. Each setup had dependencies, authentication, session management, and token issues like that. That's why automation here isn't just nice to have. It's essential. Cypress help us to tell all these flows end to end across multiple environments with both speed and confidence. So when it's come to IAM system, testing isn't just about checking if a user can log in successfully. It's validate the entire chain of automation and authorization that's real user rely on, and every step has a direct impact on both security and user experience. With Cypress, we automate some of the most critical IAM flows, like authentication flows like multi-factor authentication with TOTP and QR code, password logins, and federated SSO OIDC XAML, and authorization and session management, role-based access, consent screen, token issue, timeouts, and identity federated and multi-tenancy, where user log in through different organizations or external IDPs, user self-service flows, and security controls. We were able to automate all these things with the Cypress tool. Um, Okay, so far I will talk about the concept continuous delivery, quality engineering, and why Cypress is such a great fit. But it's one thing to see slides and bullet points, and another to see its actual work in practice. In the next part, I will walk you through the real-world cases study of how we use Cypress in test enterprise IAM flows. Okay, let's start with one of the biggest improvement we made to our Cypress suite, optimizing how test data is created and cleaned up. In the early days, our tests relied heavily on UI to data creation and cleanup, like create user application and do configuration. It's worked, but it was slow, flaky, and hard to automate. So we decided to move all that logic to the API layer. Now our before and after hooks handle setup and cleanup through APIs. That means each test starts with clean create data and ends by clearing everything out. No manual cleanup, no leftover stats from the previous runs. This small architectural shift gives us a huge performance boost. Our runs become faster, more stable, and consistent across environments. It's a simple change, but actually it's transformed how confident we can run large IAM test suites. And another big optimizations we made was around login handling, something that's especially important in IAM testing. In our test suites, we often need to log in multiple times, sometimes to the admin console, sometimes to different user applications, and doing that through the UI every time became a bottleneck. So instead, we start using Cypress session to store authenticate states. Once a user login, Cypress save that sessions and reuse it across in subsets of tests. This means we keep repetitive login steps, cut down test execution time, and keep flows consistent since the same sessions context is maintained across tests. It's a simple but powerful trick. And also our IAM automation framework is designed like a Lego set, built from small reusable Cypress commands. Enhanced commands act as a unit component. For example, one for user creation, one for app setups, another for token introspection or logging. When someone writes a new test, they don't have to start from scratch. They can simply combine these existing commands to create full test flows. So this makes our framework highly modular and maintainable. Developers and QV both use the same set of building blocks, which ensure consistency and reduce duplications. In short, these custom commands are the foundations of our IAM test framework, enabling a rapid, standardized test development across the team. One challenge in IAM testing is verifying email-driven authentication flaws like magic links, OTPs, and password reset. Gmail doesn't allow automated login, so we used Gmail REST API instead. We first create Google Cloud Apps and enable the Gmail API. This gives us a secure, official way to access the mailbox data through REST APIs. No hacks or browser automation. We then generate a refresh token. This token acts like a long-term key. It lets Cypress get access token on demand without needing to log into Gmail every time. It's completely secure and follow Google Auth2 flows. Once connected, our Cypress command use Gmail API calls to fetch the latest email, pass it, and extract where we need, whether that's an OTP code, a magic link, or password reset link. The test then automatically visit that link or enter the code to continue the IAM flow, just like a real user world scenario. Let me show you a short video of one of our automated multi-factor authentication test running. Here you can see, and before blocks, we are creating data from APIs. And here we are logging to the admin console, and from username and password, from the APIs, we already created the application. So here, application configurations will be done with the multi-factor authentication. So first factor as the username and password, and the second factor as the email OTP. Application search will be done, and configuration start. You can see first factor added and the second factor also added as the email OTP. Then it start the end user scenario. End user will access the application, the configured application, and you can see it asks the OTP verification. Then from the Gmail APIs, we will be like access the inbox, and we extract the OTP from the email body and paste here. Yeah, so you can see this 404, that's because the sample app isn't deployed in the environment, but you can see the in the URL code is there. So the authorization code is there, which we can actually exchange for a token. So, okay, to wrap up, what we see today is that continuous delivery isn't just about speed, it's about confidence. And that confidence comes from quality engineering, where testing isn't phase at the end, but something that built in from the very beginning. For us, that cultural shift backed by the right tooling, made all the difference. With Cypress, we were able to automate IAM scale scenario, ensure reliability across environments, and reach a point where we can release to production every single day safely and confidently. That's the real power of combination continuous delivery, quality engineering plus Cypress. Um, whether you are testing a SaaS platform or an enterprise system, the message is the same: build quality early, automate smartly, and deliver continuously. Thank you all. Thank you so much for joining me today. And I hope this inspire you to strengthen your own delivery pipelines through quality engineering and Cypress.